No viewers so far. What is it you did? Okay. Yesterday we have seen some conceptual questions on molarity. Today, so we're going to do some conceptual questions on mole fraction. So the first and foremost question I have written on the board. So I can read it. The sum of mole fractions of all the components is equal to dash. Number 2, which of the following has no units? Mole fraction, specific gravity, molarity, and I can add some more. One is normality also. So can I answer my question? Okay, I'll just finish up the session by giving you the answers for these questions. So here the answer is just nothing but 1. So in a binary solution, we can say the number of moles of A and B is equal to 1, which I can call it as XA plus XB is equal to 1. In a tertiary solution, we can say XA plus XB plus XC is equal to 1. So whatever will be the number of components, the total or the sum of the mole fractions of all the components in a solution, all the components in a solution is components in a solution. The solution is equal to 1. So this we can understand from this x for a binary solution XA plus XB is equal to 1, and for a tertiary solution. So this is binary solution means 2 components, and it's a tertiary which contains 3 components, and quaternary 4 components like that. So which are the following as mole units? Mole fraction, specific gravity, molarity, normality, etc. Here in this question, mole fraction and mole specific gravity, these two are relative terms, so which does not have any units. I'll write the answer here. No units for mole fraction and specific gravity. Density will have the units, that is grams per hour. But the density of a solution, when compared to the density of a water, then you will get nothing but the specific gravity. So which does not have any values, sorry, units. Means it is nothing but the relative densities. It's nothing but the ratio between the density of a solution and the density of water. So that is nothing but specific gravity of that particular solution. So mole fraction as well as specific gravity does not have any units. These two are very important basics of mole fraction. Then let us go for some numericals. First problem, right? The mole fraction of NaCl in a solution containing 1 mole of NaCl. The mole fraction of NaCl, sodium chloride, in a solution containing 1 mole of NaCl in 1000 gram of water is much.
Good morning, sir.
Morning. Hello. Hello.
Hello, sir.
Okay, look at this question. The mole fraction of NaCl in the solution containing 1 mole of NaCl in 1000 grams of water is. Here we need to identify the mole fractions of NaCl and as well as water. So how can we get it? So water already is given 1000 grams. Then the number of moles of water, number of moles of H2O is equal to weight by molecular weight, which is nothing but 1000 by 18. And similarly, the molecular weights of NaCl is equal to Na is 23 and 20 is 35.5, then which becomes 58.5 is the molecular weight. So if I take 58 grams of NaCl, it's nothing but 1 mole. It's nothing but 1 mole. So here 1000 by 18, this comes around some 55.5. So 55.5 moles of water and 1 mole of sodium. So the mole fraction we can calculate by this. Mole fraction of NaCl is equal to mole fraction of any substance is nothing but number of moles of that substance by the total number of moles. So this substance mole fraction of NaCl, number of moles of NaCl is just nothing but 1. So 1 plus 55.5, which is nothing but the number of moles of water. How I got it? Number of moles of H2 is equal to weight by molecular weight. Weight is given 1000 grams, molecular weight is 18, so 1000 by 18, 55.5. So now the mole fraction of NaCl is nothing but 1 by 56.5. 1 by 56.5. So this comes around 0.0177. This is the mole fraction of sodium. Here, try to understand the question properly. Simplification is not the big deal, but from the data in the question, we have to arrive the answer. The mole fraction of NaCl in a solution containing 1 mole of NaCl. So here I got the information. 1 mole of NaCl is nothing but 58.5 grams of NaCl. This is the weight of NaCl. So 1 mole is simply is the weight what we have. So mole fraction of NaCl, how we get is water, number of moles of water in the liquid, weight of water by molecular weight. So weight of water is 1000 and molecular weight of water is 18. So number of moles of water in the liquid is 55.5. So the mole fraction of NaCl is nothing but number of moles of NaCl is nothing but 1, and number of moles of solute plus solvent, solute is 1 and solvent is 55.5. So it's nothing but 1 by 56.5 is equal to 0.0177. Is the mole fraction of sodium chloride present in 1 mole of NaCl in 1000 grams of water.
We cannot see what is down, sir. What it is. Sir, we cannot see what is down of the board, sir.
Hello.
Sir.
Are you following?
Sir.
Okay.
Sir, we cannot see what is there on down, sir.
I'll go for another problem. A solution contains.
Sir,
Sir, the down part is not visible.
sir, in the bottom we cannot see the board, sir.
Sir? Sir, we cannot see the board, sir.
Hello?
A solution
Enti?
contains
Sir,
Sir.
1 mole of alcohol,
Yeah.
1 mole of alcohol and 4 moles of water. The mole fraction of water is 1 mole of alcohol and 4 moles of water. The direct is moles. So, total number of moles is equal to 1 plus 4, nothing but 5. So, mole fraction of H2. So, H2 how many moles we have? 4 moles. So, nothing but 4 by 5. So 4 by 5 is nothing but 0.8. So it is yes, 0.8. 40 is 0.8. And same manner, everything begins with the mole fraction of water. So mole fraction of alcohol, mole fraction of alcohol. So we have 1 mole of alcohol. So it's nothing but 1 by 5. So 1 by 5 is nothing but 0.2. A solution contains 1 mole of alcohol and 4 moles of water. The mole fraction of water is, so it's nothing but number of moles of the component. So they are not people. Some people are joined. A solution contains 1 mole of alcohol and 4 moles of water. The mole fraction of water is total number of moles is nothing but 1 plus 4, 5. Mole fraction of H2O is equal to number of moles of water, that is nothing but 4, and total number of moles is nothing but 5. So 4 by 5 is nothing but 1.8. Similarly, we can also calculate the mole fraction of alcohol, where the number of moles of alcohol is 1 and total number of moles is nothing but 5. So 1 by 5 is nothing but 0.2. Hello. Are you following me?
yes sir.
So first 2 problems also have you seen? First 2 problems have you seen?
Yes sir.
You're
Yes,
comfortable? So now in the first problem, what I asked is the sum of the fractions of all the components present in a solution is equal to 1. So if it is a binary solution, it's nothing but XA plus XB is equal to 1. If it is a tertiary solution, XA plus XB plus XC is equal to 1. Now in this case, in this problem, say there are 2 components which is nothing but the water and the other is nothing but alcohol. So the number of moles, the mole fraction of water is nothing but 0.8, and the mole fraction of water is nothing but 0.2, and the sum of the 2 mole fractions, 0.8 plus 0.2 is nothing but 1. Are you able to follow me the same?
Yes, sir.
Come on, please speak up. The sum of the mole fractions of all the components present in a solution must be equal to 1. That is nothing but mole fraction. So here you can also check in weeklies if you are finding mole fractions of both the components present in the solution, like the solute and solvent. In this question, the solution contains 1 mole of alcohol and 4 moles of water. The mole fraction of water is. This is the question I asked you. So, total number of moles, nothing but 1 plus 4, 5. The mole fraction of water is equal to 4 by 5, nothing but 0.8. And you can also calculate the mole fraction of alcohol, which is nothing but 1 by 5, nothing but 0.2. So, the sum of the mole fractions of all the two components is equal to 1, nothing but 0.8 plus 0.2 is equal to 1. Are you comfortable?
Yes,
Are you
sir.
comfortable?
Yes, sir.
Yes, sir.
Okay, then the next question I'll go for. Did you copy this question?
Yes, sir.
What's happening? Some noise is coming from some speaker, which is no good at all. Please mute your mic unless you want to speak something really you need to speak. Okay? So other than just only just listen. Whenever you want to speak, that time only you want to switch on your mic so that you can speak. So next problem, I want to write an aqueous solution of, come on, write it. An aqueous solution, aqueous solution, aqueous solution of methyl alcohol, METH by methyl alcohol, contain 48 gram of alcohol, 48 gram of alcohol. The mole fraction of alcohol is 0.6. Okay. Already I gave you the mole fraction of one thing. The weight of water is the weight of water is how much? Look at here. Simple. Concept is one and the same. Which is missing from there we need to identify. So here an aqueous solution of methyl alcohol contains 48 gram of alcohol. The mole fraction of alcohol is 0.6. The weight of water is. So here he has given 48 gram of alcohol also. So we have to calculate the alcohol's molecular weight. And I gave you the methyl alcohol. Methyl alcohol formula is nothing but CH3OH. So CH3OH means carbon is 12, and there are 4 hydrogens, nothing but 4, and 1 oxygen, nothing but 16. So 10 plus 2, 12, then it is 32. So methyl alcohol, 12 carbon, 4, 16, and then 16, 32, yes. So 32 grams of methyl alcohol is nothing but 1 mole. So 32 grams of alcohol is equal to 1 mole. So then here it is 48 grams is equal. 48 grams of alcohol, how many moles? So it's nothing but 48 by 32 into 1, which is nothing but 1.5 moles. 1.5 moles. 1.5 moles of. So methyl alcohol is there. And this 1.5 moles is equal to 0.6 is the mole fraction. So then what is the mole fraction of water? So if 0.6 is the mole fraction of alcohol, so 1 minus 0.06 is nothing but the mole fraction of water, it's nothing but 0.4. So the mole fraction of water is 4. Okay. So if 0.6 is a mole fraction which is equal to 1.5 moles, then if it is 0.4 is a mole fraction which is equal to how many moles? So then 0.4 by 0.6 into 1.5. This gives rise to moles of water. So can you please calculate how much it comes out? 0.6, 0.4 by 0.6, 0.4 by 0.6. How many times?
The one.
So, it just simply 1 unit. Am I right?
Yes, sir.
So 4 by 6 into 1.5 is nothing but 1 number. Right? So, one mole. 1 mole of what is nothing but 18 grams of water. So 1 mole of water is H2O. H2O is 2 plus 16. It's nothing but 18. So the weight of water is 18 grams. Answer is 18. You followed it? What I am doing?
Yes,
You
sir.
just look at the problem. And what I am talking is an aqueous solution of methyl alcohol containing 48 grams of alcohol and the mole fraction of alcohol is 0.2. The weight of water is we need to find out. So what I did here, just I found so 48 grams of what alcohol is how many moles? So by knowing the molecular weight of methanol, which is nothing but 32. So if I take 32 grams of methyl alcohol is nothing but 1 mole. So 32 grams of alcohol is 1 mole. So 48 grams how many moles is nothing but 1.5 moles. If 1.5 moles is equal to 0.6 mole fraction, then we know the mole fraction of water also. So if the alcohol is 0.6, the other component should be 0.4 only. That is nothing but 1 minus 0.06. So 0.4. So 0.4 is equal to how many moles? Nothing but 1 mole. So 1 mole of water weight is nothing but 18 grams. So 18 is the answer. Okay.
Yes, sir.
Is it happy? Able to follow?
Yes, sir.
Yes, sir.
So when you look at the same kind of problems anywhere also you must be able to do it. Just not only the problem what is. That's why I'm asking you to check the problem. See what is given. Already if something mole fraction is given means one mole fraction is given in a binding solution means we know the mole fraction of other also. Because the sum of the mole fractions of all the components is equal to 1. So if it is 0.6 mole fraction of one component, then definitely 0.4 is the mole fraction of the other component, and then added together it becomes 1. Okay? So if it is, this is given means the other is also given. So here the weight is given means by the help of the molecular weight we can also find out the number of moles of that. So then equivalent number of moles we can calculate. So the same, very simple. Okay? But you should apply the concept of a binary solution whose sum of the mole fractions of all the components is equal to 1. So that you can get the number of moles of both the components. Okay. So now I'll go for another problem. Yeah. Next problem. Come on, write down. The mole fraction. The mole fraction of solute. The mole fraction of solute. 10% weight by weight. 10% weight by weight. Aqueous is aqueous NaOH solution. The mole fraction of solute in 10% weight by aqueous solution is dash. Oops. So here, whenever you look at the percentage, and the relation here. It is weight relations. So 10% weight relation means it's nothing but 10% solute means the 90% is nothing but the solid. So means here we can say 10% solution means 10 gram of NaOH. 10% solution means 10 gram of NaOH, sodium hydroxide, in 90 gram of water. 90 gram of water. Why? Because here it is given weight. So then, what is asking mole fraction solute? So how do you get the mole fraction? We wrote the number of moles. So molecular weight of NaOH is 40. So MOL NaH weight NaOH is equal to 40. That we know pretty well.
40.
So the number of moles is equal to 10 by 40. Okay. 10 by 40 is nothing but 1 by 4. 1 by 4 is nothing but 0.25. So the number of moles of NaOH is 0.25. Now let us come back to the number of moles of water. Water weight is 40. 90 grams we have. So number of moles of, say, 90 is the weight of water and molecular weight of water is 18. So 90 by 18 is nothing but 5. Is nothing but 5 moles of water. 5 moles of water. So how we got weight of molecular weight of the number of moles. Now the total number of moles is nothing but total number of moles is equal to 5 plus 0.25, which is nothing but 5.25. 5.25. So what we need to find out the mole fraction of solute. So it is nothing but NaOH. So NaOH is 0.25. So thereby mole fraction and NaOH sodium hydroxide is equal to 0.25 by 5.25.
0.047.
Yeah, you are right. And sometimes they may be asking the answer in terms of fractionals. First of all, you convert this into fraction. So 25 by 525 is nothing but a fraction of 1 by 21, am I right? 1 by 21? Yes. In 525 goes to 20 times and 125. Why 25 is equal to 1 by 21. So 1 by 21 is 0.04 something. 0.047.
7.
Okay. So you must be first you always convert into fraction only. Okay? And then you find out the decimal values. Okay. Is it okay?
Yes.
Come on, speak up.
Yes, sir.
Okay, and I would like to ask you, did you finish doing all the problems in the textbook? Did you finish doing all the problems in the textbook? Okay, don't worry, do it leisurely, but you must do it. But you must do it. And you have the emails, no email address. So in case if you have any problem, so you want to have any explanation for anything, then you can also email me so that I can answer you by mail.
Okay, sir.
So you try, but see, finish it off. See, I asked you to do it by today itself. You didn't do it, but at least you have to tomorrow or within 1 or 2 days finish up that. But don't leave like that. Only just one chapter we are able to finish. That chapter should be thorough in all levels, the board level, the LGS level, and the other levels also. And continually, if you do that, you will not forget the concept. Okay. So I am just introducing these conceptual questions, and it's only stage 1, level 1 and level 2 questions I am asking, and level 3 questions you need to try on your own. And there is every chance you will stop halfway, then that time I will pitch into that. Then I will solve the problem. Right?
Yes, sir.
The next question I will give you. The mole fraction of solute in a solution is the mole fraction of a solute in a solution is 0.3. The mole percent amount, the mole percent of the solvent is, don't write anything on the book, just to read the question and type it out. This is an LKG question amount. Apply the concept and tell me the answer.
0.7. I mean,
So that percent means
70%.
multiplied with 100 is 70. See, mole fraction of one component is 0.03, so then the mole fraction of other component is nothing but 0.3 means 0.7. And mole percentage means 0.7 into 100. 0.7 is nothing but 70%.
70%.
Is it okay?
Yes, sir.
So for this question, there is no need of pen and pencil. Just by looking at 0.3, then the other component should be 0.7. 0.7 into 100 is nothing but 70. It's a simple problem. Provided you know what is mole percent. Moles into percent is nothing but mole fraction in percent is nothing but mole percent. Okay? Right. So this question is very simple, but you need to think. So now we move for the next question. So next question. 16 grams of NaOH, sodium hydroxide, is present in 100 ml of an aqueous solution. The aqueous solution. Its density, I'm giving you the density, is 1.06 grams per ml. What is its mole fraction? Come on, anybody solve the problem and tell me how you solve it and what is the answer?
Sir, move, sir. You're not able to see the board. Can you please move, sir? You're not able to see the board.
Sorry? Once again, I repeat the problem, you can note it down. 16 grams of NaOH.
Sir, can you please move, sir? We're not able to see the board.
I need to move on. Now is it okay? 16 gram of NaOH is present in 100 ml of an aqueous solution. Its density is 1.06 gram per ml. What is its mole fraction? What is its mole fraction? I am asking about the mole fraction. And do and tell me. And then you tell me the answer, and then I'll ask you how you did it, how you got it. Got the problem, all of you?
No, sir.
No, sir.
You are not able to find the solution.
Yeah, 1 minute, sir.
Yes, solution.
You think for a while and look back your notes and all and try to find out the way to solve this problem. And anyway, I will solve it. It doesn't mean that you need, so no need to try. You try and you work. At least halfway you must be through. Some idea you should get how to solve the problem. I'll give you 5 minutes, 10 minutes time, no problem. You try to do one. Another 3 problems. I want to see you people doing it.
Okay, sir. Malay
I only at the end, the last 10-15 minutes, I will show you how to do it. In the meantime, one by one you show it, you solve it, and let me know what is the answer and how you did it. And only in the last 15 minutes, I will give you the solution for this another 3 problems. You must go on your own. I'm just coming back.
ಮೂತಲ ಪ್ರತಕ್ರ 1000 by what?
This is a minute is 100 ml of an aqueous solution.
Anybody got? Lakshmi Priya?
Just
No, sir.
about to finish, sir. 2 minutes.
Alekya. Rohan, what's happening with you?
Sir, I'm doing, sir.
How much time, man? Very simple. See, I'll give you the clue.
Density is equal to mass by volume, and we need to find mass, no, sir?
Density is given. See, when density is given, you can find out the total mass of the solution.
Yes, sir.
16 gram of NaOH is present in 1000 ml. 100 ml. How much ml?
100 ml.
100 ml. So then you can get the weight of 100 ml. Huh?
Yes, sir.
100 ml multiplied by the density, you get the weight of
106 grams, sir.
yeah 106. So the weight of what will be
106.
16 grams of NaOH is there and total weight of the solution is 106 grams. Then what is the weight of water? What are you doing? Total weight of the solution is 106 grams.
Sir, answer.
NaOH plus water is 106 grams. Then what is the weight of water?
Sir, 90.
Sir, 9.
That's what. 16 grams of NaOH already I gave you. So then 106 minus 16 nothing but 90 grams. 90 grams is the weight of water. So then now find out the number of moles. NaOH number of moles is equal to 16 by 40, which is nothing but
0.5.
4 by 10 nothing but 0.4. Then number of moles of water is equal to
5.
9.
90 by 80 nothing but 5.
95.
So total number of moles is equal to 5.4. So mole fraction of sodium hydroxide is 0.4 by 5.4. So 0.4 by 5.4 is nothing but 4 by 54, which is nothing but find out the answer. How many times? 34 the 52.
Sir, mole fraction of the solution.
13.5.
Yes,
So
sir,
13.5. Which is nothing but 2 by 27.
13.5.
Yeah, and the call I got frozen in the call. Raj. No problem. Look. See, this is very simple problem. You are not getting the idea. Alright? So at least next problem. So think how to do it.
అవును నాకు రాదు
Okay.
చేసుకో
This
Yes,
problem
sir.
everybody do? Get it? So now I'll write the another problem.
0.67.
That is just simply 2 by 27 or 1 by 30.5. If you simplify whatever you get, that is fine. Right?
అందరు చిన్న
But here the method what you are applying is most important. Okay. Now another problem. Calculate. Calculate the mole fraction of solute, mole fraction of solute in 2m aqueous solution. A2m aqueous solution of acetic acid. ACETI, acetic acid. The density of the solution, the density of the solution, the density of the solution is 1.02 grams per ml.
ml.
వెళ్ళరా
So very simple.
వెళ్ళరా చెప్తారా పోతే
Acetic acid formula CH3COOH. So CH3COOH means there are 2 carbons, nothing but 24, and 4 hydrogens, nothing but 4. There are 2 oxygens, nothing but 22. So 10, so 60. So the molecular weight of acetic acid is 60. I will not do this problem. I want to hear answer from you people. You also. Tanya, what are you doing? Rohan, any answer?
Sir,
Yeah, come on, tell me.
I'm not sure if it's right.
Okay, no problem. Tell me what you did.
Sir, calculated the atomic weight of acetic acid.
Molecule.
Not atomic weight, molecular weight. Okay, yeah. That already I told you. So that is nothing but molecular weight of acetic acid is 60. Okay,
Then I found that in 2 moles of aqueous solution there will be 120.
yes. 2m solution means 120 grams. 120 grams in how many ml?
In
So if it is 60 grams in 1000 ml, it is 1 molar. If it is 120 grams in 1000 ml, then it is 2 molar. So means
2000 ml, 2 liters.
so 120 grams in 1000 ml is nothing but 2m solution. So then, what is the weight of the solution? So what will be the weight of solution? I gave it the density.
Once more.
So 1000 into 1.02, it gives like the weight of the solution.
Sir, can
Sir,
you?
1020.
Yeah, 1020. So then weight of water is equal to?
Sir, can you explain the problem once again?
Yes, I will explain. So then weight of water, Rohan?
Sir, 900.
Yeah, 91. Then what is the mole fraction of number of moles of water?
Sir, calculating, sir, 1 second.
Yeah, 900 by 18
50.
is 50. So number of moles of acetic acid? 120 by 60. Nothing but 2.
2.
So then the mole fraction of acetic acid is equal to 2 by 52.
11.
2 by 52 is equal to 1 by 26. Is it okay?
Yes, sir.
0.03, sir.
Yeah, that is nothing but mole fraction of acetic acid.
Yes,
So
sir.
for all of you people, just listen once again. I will show you the same thing. See, here we have calculated the molecular weight of acetic acid nothing but 60. So if I dissolve 60 grams in 1 liter, that is nothing but 1000 ml. It is nothing but 1 m solution. So I am having 2m solution. 2m solution means nothing but 120 grams. 120 grams in 1000 ml. It gives us 2 ml. So now, weight of acetic acid is nothing but 120 grams. So the number of moles of acetic acid, number of moles of CH3COOH is equal to weight by molecular weight, nothing but 120 by 60, which is nothing but 2. So number of moles of acetic acid is 2.
Sir, won't that be 2000 ml?
Sorry?
Won't 120 grams 1000 ml?
See, what is a molar solution?
That's
If 1 mole of solute is present in 1000 ml, nothing but 1 liter, that is nothing but a 1 molar solution. Okay. So 1 mole of acetic acid is nothing but 60 grams of acetic acid.
Okay, sir.
So 60 grams of acetic acid in 1000 ml is nothing but 1 molar solution. So if it is 2 molar solution, the amount should be double. So nothing but 120 grams. So 120 grams in 1000 ml gives us 2 m solution. So the number of moles of acetic acid is nothing but 120 by 60, nothing but 2 moles. So I got the number of moles of acetic acid is 2. The next, what is left is, I gave the density of the solution. So density of the solution is 1.02 grams per ml. So here I got the 1000 ml of the solution. So the weight of solution is equal to 1000 into 1.02. So that gives us 102,000. Then after 2 figures, like 0 point something like 1020. So 1020 is the weight of the solution. So weight of the solution is nothing but weight of solute plus weight of solvent. Okay. So once if I know the weight of solute is nothing but 120 grams, then I can get the weight of solvent. So weight of H2O is equal to total weight of solution is 1 and weight of solute is nothing but 120 grams. So 120 minus 120 is equal to 900. So 900 is the weight of water. So once if I know the weight of water, I know the molecular weight of water. So 900 by 18, 18 is the molecular weight of water.
50.
So that's about 50. So I got 50 moles. 50 moles of number of moles of water is 50. So now coming to the mole fractions. So 2 moles of acetic acid and 50 moles of water. So total is 52 moles. And the mole fraction of acetic acid nothing but 2 or 52.
Sir, I cannot see the down part.
Oh, okay. But anyway, you please listen to me, you can understand.
Okay, sir.
I'll explain once again, don't worry.
Okay.
I don't get confused, I'll explain once again. Every point, again and again, try to catch the word.
Okay, right.
But once if you listen to a statement that you should be recorded in your brain, that is what I'm asking. Here, 16, so calculated mole fraction of a solute in 2M aqueous solution of acetic acid. The density of the solution is 1.02 grams per ml. So here first I am calculating the molecular weight of acetic acid CH3COOH. So CH3COOH molecular weight is 2 carbons means 24, 4 hydrogens means 4, and 2 oxygens means 32. Total it is 60. So now the second step. 60 grams in 1000 ml gives rise to 1 ml. So definitely we have 2 ml. So if it is 2 ml solution, so in 1000 ml, that the amount should be 120 grams. So we got the weight of acetic acid. Okay. And we know the molecular weight of acetic acid. So number of moles of CH3COOH acetic acid is equal to weight by molecular weight. Weight is 120, molecular weight is 60, nothing but, so it is nothing but 2 moles. Now coming to the solvent. Solvent weight we don't know, but density is given. Density is 1.02 grams per ml. So it is nothing but 1000 ml of solution we have. So weight of WBN is weight of solution. Weight of solution is nothing but weight of solute plus weight of solvent is equal to 1000 into 1.02, which is nothing but 1020 grams. Do you agree with that?
Yes.
So then weight of solute solvent, weight of solvent is equal to total weight of solution nothing but 120 minus weight of solute nothing but 120. So once you know the weight of solvent, then you know the molecular weight of solvent. So molecular weight of solvent nothing but H2O. Solvent H2O molecular weight is equal to 18. So number of moles is equal to 900 by 80.
50.
So now we got the number of moles of solute and solvent. One is 50, other is 2. So I will write the same. Again I am coming down. So number of moles of solute in brackets acetic acid CH3COOH is equal to 2 number of moles of solvent.
52.
which is nothing but H2O
50.
is equal to 50. So, mole fraction of solute is equal to mole fraction of solute. Nothing but acetic acid, CH2OH.
2 by
Equal to the 2 is the number of moles of solute and total number of moles is nothing but 50 plus 50.
52.
So which is nothing but 1 by 26.
0.03.
Yeah, whatever you get. That is fine. I hope you got the concept how to do the problem.
Yes, sir.
Yes.
Here basically we need to identify the number of moles of both
Sir,
the
sir,
components.
why did we get 52?
50 plus 2.
50 plus 3 mole fraction of solute is equal to number of moles of solute by number of moles of solute plus solvent. Mole fraction can be defined as the ratio between the number of moles of solute to the total number of moles of solute and solvent. Okay?
Yes, sir.
So you are forgetting the concept. That is only the statement I am asking you to remember. The same thing you need to apply. Nothing more than that.
Okay.
So whenever the problem is related to, remember this clue in your brain. Whenever the problem is related to mole fraction, remember somehow we need to identify the number of moles of both the components. I mean the solute and solvent. First of all, we need to identify the number of moles of both solute and solvent. So for which we need to think. So one is given directly and the other is we have to calculate indirectly. But somehow we need to identify the number of moles of both solute and solvent. And so thereby we can calculate the mole fraction of any one of the components. Okay? You getting my point?
Yes, sir.
Wow, super. So finally, I want to ask you, did you finish doing the problems in the textbook? Did you finish doing the problems from the textbook, all problems?
No, sir.
Some have
No,
to
sir, not all.
do.
You are left.
Some have to do.
Okay. Then see, you do one thing. You please note down the email address, my personal email address.
One second, sir.
Yeah, Uday BT,
Uday?
Uday BT, B for Mohammed, T for Tata.
Sir, Uday? Can you write it on the board? Sir?
Yeah, I write it on the board. UDAY, Uday BT 2000. Uday BT 2000 at gmail.com.
Sir, is that BT?
Yeah, BT, B for Bombay, T for Tata. Uday BT. You know BT Brinjal?
Sir, BT, in between Uday and BT there is space.
No space.
Between
There is
BT
no
and
space.
2000.
Just Uday BT 2000, no space anywhere.
No
At
space.
gmail.com.
No space.
Sorry?
Capital U.
No capitals, all small letters. All small letters. No gap.
Okay, sir.
So you just mail me which problem you are not able to get. You just write the problem and send it to me and the problem number. And what you did. What you did. See, unless you try something on your own, I will not answer you. I want to see that you are attacking the problem. You are trying to do the problem to some extent, and somewhere else you stop. Then from there I will take you to the end. Just simply if you ask me to do the whole problem, every problem, no, sorry, I won't do it. I want to see your efforts. What is the effort you are putting on the problem, and to what extent you are able to move. Then from there I will take you to the next step. I will explain everything in detail in the mail and you will get the answer. But be thorough with this chapter by the time you come back to the school after finishing holidays. Okay.
Yes, sir.
Then fine. So now you got this and you better send it. So you send a mail to my this address now itself.
For what, sir?
Now itself you send a mail to my address. So if I get any mail, then I can confirm that you are sending it right.
Sir, I sent you.
You have sent that or just yeah.
Srinivas.
Sir, what should we send?
Hello, sir. Or something like that.
Is it Srinivas K?
Yes, sir.
Okay, then another Bharat Chandra.
Yes,
Sir,
sir.
what should we send, sir?
Yeah, yes. So
Something.
you
Hello.
know my address.
Send anything.
Yeah, fine. That's good. Fantastic. So you have anything? You just mail me. I'll answer you within 24 hours.
Thank you.
Okay? All right. So then next, let's go ahead with the other questions. What else? Yeah, and last question, which I will give you some time to find out the answer. I wait for you to solve. Here, this involves some knowledge also, and this knowledge definitely you should have it by this time, and that is in 10th standard. By the time you finish your 10th standard, you should have that knowledge minimum, and basing on which you can solve the problem. The second part of the problem, already I taught you, you can solve it very easily. I have it. The first part of the problem, you need to have some knowledge. And what is that? Have a look at this problem. Okay. Maltose, you know maltose? Maltose is a
It's a
sugar.
type of glucose.
Yeah, maltose is converted. Maltose is converted into A. What is this A? I don't know. By maltase. Maltase. And maltase is an enzyme. Nothing. The mole fraction. The mole fraction. The mole fraction of A in 10% weight by weight aqueous solution is approximately how much? I give you 10-15 minutes time. If you can do it fast, that's fine. Not 10-15, 5 minutes only. I'll give you 5 minutes time. So I need to teach you something more.
Sir, can you please move?
Okay, I'll see.
Sir, we don't know the formula of maltose and Sir,
Yes.
we don't know the formula of maltose and maltase.
Sorry.
We don't know the formula of both the compounds, sir.
You must know what is maltose and what is A. Otherwise, you cannot do it. You should know what is maltose and maltose formula. Then maltose, when it is reacted to maltase, what is the product obtained? And the product's molecular formula, if you know, then only you will do it. Otherwise, you cannot.
Sir, can you once read the question?
Maltose is converted into A by maltase. Means maltose, by the action of an enzyme maltase, it is converted into A. So that A, you don't know what is an A, what is it? So that is one knowledge based question. Next thing is the mole fraction of A in 10% weight aqueous solution is approximately how much? So if I give you the answer what is A, you can do this problem very easily. When you know the weight percent, what is there? Just simply 10% of the solute and say 10 grams of solute and 90 grams of solvent. Then simply by knowing the molecular weights. So 10 by molecular weight of A is nothing but the number of moles of A, and then the 90 by molecular weight of solution, as you said, is nothing but water. Then you get the number of moles of water also. So once you know the moles of A as well as water, then you can
The
calculate.
maltose is C12H22O11.
O11.
Maltose is
C12H22O11.
fantastic. Then what is the action of maltase? Maltose is converted into what? Find out from the Google. Maltose, by the action of maltase, what it becomes?
Sir, it says it's the same thing.
It is there in the book. It is there. If you can see Google, you can get it also. Or else, regularly, somebody may be drinking Maltova at home. Bonvita Maltova. There's a drink, health drink Maltova.
Yes, it is there.
What is Maltova?
Glucose.
Yeah, so it is nothing but maltose. Maltose, by the action of maltase, it becomes dash.
Glucose.
That's what. So A is nothing but glucose. Then what is the formula of glucose?
D6H12O6.
Then what is the molecular weight?
180, sir.
180.
Then do the problem. Simple, you got it.
Sir,
Yes.
I didn't hear you. What you tell?
See, glucose, you know the formula, then calculate the molecular weight of glucose. Once you know the molecular weight of glucose, then nothing but the weight percent is given. So 10% of glucose means 10 grams of glucose present in 90 grams of water. So 10 by molecular weight of glucose gives us the number of moles of glucose, and 90 by molecular weight of water gives us the
Says maltase a catalyst. I mean, in that.
maltase. Maltase is the enzyme.
Yes, section enzyme.
You know, maltose is a disaccharide, just like sucrose. Sucrose is a combination of glucose and fructose, and maltose is a combination of glucose and glucose. Maltose and sucrose both are disaccharides. In case of sucrose, if 1 unit of glucose combined with 1 unit of fructose, whereas it is with maltose, both the units are glucose only. So maltose by the action of maltase gives 2 molecules of glucose, and sucrose by the action of invertase it gives us a molecule of glucose and a molecule of fructose. Both the molecular formula for both the glucose and fructose are going to be the same. In one it is that fructose is the keto form and glucose is an aldo form. Molecular weight is going to be the same for both glucose and fructose. Okay, so that we get in 8th standard. Sometimes you have the preparation of ethyl alcohol and all is there. But it's another question. But anyway, now you know what is maltose and what is sucrose. So you want to answer?
1 second, sir. One second, sir. Sir, is it 0.16?
Yes, you're right.
Yes, sir. 0.16.
0.161.
Oh, fine. 0.1 is 0.16 is really fantastic. That's good. Okay. Then I'll give you another 5 minutes time. What I'm asking you to go through the entire entire chapter, right from the significant figures to mole concept and all the 4 methods of concentration terms. That is mole fraction. 5 methods I gave you, no? Molarity, mole fraction, mass percent, and then ppm, parts per million. And there is one more term you can easily understand that one. If I say ppm, if I say ppm,
Parts per million.
parts per billion, then what it would be?
Molality.
No, see, if it is 10 power 6, it is parts per million. And what about the parts per billion?
10 power 8.
Mm-hmm.
7.
9.
Oh, 9.
10 power 9 is parts per billion. Okay, such questions I will ask you. Just a little bit extension of what we did. But most of the time I'll ask you only the definitions part and the formula part. Okay. So what is a mole? What is GMP? So like that.
The
What is
basic.
mole fraction? All definitions I will ask you.
You
So
ask
you just go through
Will
it.
it last now or when?
Yeah, now itself. Now itself. Now itself. See, another 15-20 minutes time is there. I'm giving you 5-10 minutes time. Just go through the definitions.
Sir, that's it, sir. Chapter done.
Yes. Anything else you want? You just ask.
Yes,
So
sir.
tomorrow class is there, sir.
Tomorrow no class for chemistry. You may be
Yeah.
having physics.
Day after.
Day after also you may be having physics now.
Okay.
Physics and maths. Today in the morning what class happened?
Physics.
Physics and chemistry. So tomorrow it will be physics and maths.
Okay, sir.
Sir.
Friday and Saturday, physics and maths will be there.
Okay, sir.
Okay, sir.
And Sunday comes sometime. So whatever time, whenever you are doing problems in chemistry, just mail it. And Monday onwards, I'll give you replies. Okay?
Yes, sir.
Yes, sir.
Tomorrow, day after tomorrow, on Sunday, whatever problems you have, you just mail me, and Monday onwards you get the mails back. Okay?
Yes, sir.
Right. So now I'm giving you another 5-10 minutes time. Just go through, and I want to hear from you people the definitions. I just want to have a look into the textbook also. If anything I left there, then I will see. Ah, yeah. So there is a thing for Chris. Yeah, I've seen the textbook where you have laws of chemical combinations also there. That is law of conservation of mass. It states that matter can neither be created nor destroyed. Name of the scientist Lavoisier, and is next law of definite proportions given by French chemist
Law of
Joseph
multiple
Proust.
proportions.
Given compound always contains exactly the same proportion of elements by weight. The next law of multiple proportions. So again, it is nothing but the ratio between the combining elements only. So if two elements can combine to form more than one compound, the masses of one element that combine with the fixed mass of other element are in the ratio of small whole numbers. Again, it's nothing but a ratio thing. Next, Gay-Lussac's law of gaseous volumes. This law was given by Gay-Lussac. When gases combine or produce in a chemical reaction, they do in a simple ratio. The volume produced by all gases are at same temperature and pressure. So again, it is nothing but the ratio between the volumes of the gases. All are same, and you just only go through the definitions and all, and just have an idea also. That will be better. I'll just show you all these four laws. Very simple. 5 minutes time. Give me 5 minutes time. Law of conservation of mass. Matter can be neither created nor destroyed. Means it just nothing but a number of atoms of all the elements present on the right hand side are nothing but the reactants must be equal to the number of atoms of all the elements present on the left hand side, sorry, right hand side, which is nothing but products. So for example, if I take C2H6, ethane is there. Ethane is a gas and subject to a combustion process, nothing but oxygen. You remember well one thing, any hydrocarbon, when it is burned in the presence of oxygen, the resultant products are always only carbon dioxide and water. CO2 plus water. There is no need to think of money many times. Any hydrocarbon, remember, any hydrocarbon means compounds containing carbon and hydrogen subjected to combustion process means when it is burned in the presence of oxygen, the products are always CO2 and H2. So just we need to balance, nothing more than that. So here two carbons are there, I'll get 2 CO2, and there are 6 hydrogens means I get 3 H2. So means 2 CO2 means nothing but 4 oxygens, 3 oxygens here, 3 H2 means 3 oxygens. So 4 plus 3, 7 oxygens. 7 oxygens is not possible. Okay, 7 oxygens means if I take 3 by 2 go 2, that is 5. So which is not possible. So I'll take 7 molecules of food. So 7 molecules
we
of
cannot
food
hear
means
you.
I just need to multiply it by 2 all. So 2C2H6,
Sir, it is
then
not
I'll
clear.
get 4CO2 and 6H2. Yeah. Tell me. Here, what I would like to tell you is, according to the law of conservation of mass, the weight of or the mass of reactants must be equal to the products, irrespective of the reactants and irrespective of the products. Whatever may be the products, whatever may be the reactants, but the total mass of the reactants must be equal to the total mass of the products, which is nothing but the law of conservation of mass. Law of conservation of mass. So you take this equation. So balance equation. 2 molecules of ethane when burned in the presence of 7 molecules of oxygen gives us 4 molecules of carbon dioxide and 6 molecules of water. You do this reaction anywhere, it will be like this only. It will not change. Right? And same way if I take another reaction like N2 plus PH. Nitrogen, one reaction H2 hydrogen, we get 2 NH3, nothing but ammonia. If you look at here, 2 nitrogen atoms and 6 hydrogen atoms. So in 2 NH3 also same. Here it is in the form of nitrogen and hydrogen, here it is in the form of ammonia. Nowhere related. Nitrogen properties are different from ammonia and hydrogen properties are different from ammonia. The two reactants are reacting, but the thing is, the mass remains same. The mass remains same. Say for example, you take calcium carbonate, CaCO2. When it is heated, it becomes to give rise calcium oxide, CaO, and then carbon dioxide. Right? So calcium carbonate properties are different from CaO and carbon dioxide. But if you see this base also, CaCO3, if I take calcium atomic weight is 40, carbon is 12, 3 oxygens 48. So it is nothing but 100. Calcium carbonate molecular weight is 100. So if I take 100 grams of calcium carbonate, you look at here. Calcium is 50, 40, and oxygen is 16. So I get 56 grams of calcium oxide and then 44 grams of carbon dioxide. So look at this. 56 plus 44 grams is nothing but 100 grams. Here I have taken 100 grams of calcium carbonate and the products are calcium oxide and carbon dioxide, but the mass is remains same. Meaning the mass of the reactants must be equal to the total mass of the products. The mass same and here also. Nitrogen. Nitrogen N2 is nothing but 14 plus 28. It's nothing but 28 is the molecular weight. So 28 grams of nitrogen combines with 3 to 6 2. So it means 6 grams. 6 grams of hydrogen. 28 plus 6 is nothing but 34. So if it is nothing but 17, ammonia molecule is 17. So 2 into 17 grams of ammonia I'll get, which is nothing but 34. So 34 is the total of the reactant. Total mass of the reactant is nothing but 34, and total mass of the product is also 34, which is nothing but law of conservation of mass. Okay. Law of conservation of mass states that the mass of the reactants must be equal to the mass of the products, and this law is followed by all the chemical reactions. So the laws followed by chemical reactions is nothing but laws of chemical composition. Right? So the same thing.
Formula mass.
Yeah. What formula mass?
What is it? Formula mass.
Formula mass is just nothing but molecular weight of any substance. See, generally in case of ionic compound, we take sodium chloride NaCl. Here, in this case, we call it as sodium is 23 and chlorine is 35.5. Is nothing but 58.5 is nothing but the formula mass of anything. Okay. So if it is nothing but some Na2CO3 sodium carbonate, then we call it as molecular. Molecular mass or formula mass is going to be same. Okay?
Yes.
No confusion. Formula mass and molecular mass is going to be same.
Yes, sir.
In many compounds we use the term molecular mass, formula mass. In case of covalent compounds we use the molecular mass. Say for example H2O. H2O and CO2, ammonia, NH3, these are covalent compounds. In this case, we use the term molecular mass, but whereas in case ionic compounds like NaCl, Na2CO3, NaBr, CaCl2, all these are ionic compounds. In this case, we use the term formula mass. Okay?
Yes, sir.
Sir.
Yes, come on, ask me. Law of definite
The
properties.
connection not good. Cannot good, sir. Coming.
Okay, so one
Very
more.
clearly.
Sorry?
The board is not
Board you are not able to see.
able to see the board, sir.
Now?
Yes, sir.
Yeah.
Okay, sorry.
You can see, sir.
Yeah, now you can see the board now.
Yes, sir.
So here I have given you many examples. See, formula mass means for ionic compounds we use the term formula mass. For covalent compounds we use the term molar mass. So ionic compounds, nothing but NaCl, CSCl, Na2CO3, like NaCl, ionic compound, KCl, ionic compound, CaCl2, ionic compound, Ca, like that, Na2CO3, sodium carbonate. Here we will use formula mass. Then CaO, calcium oxide, CaCl2, already available. So in this case, means in case of ionic compounds, we use the term formula mass. On the other hand, if it is in covalent compounds like H2O, molecular mass of H2, that molecular mass of NH3 ammonia, molecular mass of urea, NH2CONH2 is nothing but urea. So molecular mass of urea is so you can calculate. Like carbon dioxide is a covalent compound. So in C2H6, so we use the molecular mass. The term molecular mass for covalent compounds and the term formula mass for ionic compounds. Okay?
Yes, sir.
So now the first one is law of conservation of mass that we are seeing. And let us have a look at them. The second law, what is nothing but law of definite proportion. So law of definite proportions, whenever, see, the source of a substance, irrespective of the source of the substance contains a fixed ratio between the combined elements. So what does it mean? Let us have a look at it. Here, I'll have a calcium carbonate with me. There is a calcium carbonate when reacts with HCl, hydrochloric acid. Then I get calcium chloride CaCl2 and then carbon dioxide acid. So that is CO2. Okay. Then along with that, I can also say if I take 2HCl, I get H2O. H2O. So calcium carbonate 2HCl mixes CaCl2 plus CO2 plus H2O is the balance. Okay. Now you can this carbon dioxide is the ratio between the combining elements carbon and oxygen. Carbon 12 grams and oxygen 52 grams. Carbon is to oxygen is nothing but the ratio is ratio by weight. It's nothing but 30 to 12 is to 30. So it's nothing but 6 is to 16 and then nothing but 3 is to 8. So the ratio of these two elements in carbon dioxide is 3 is to 8 anyway. Means even in other source for carbon dioxide gas. Carbon dioxide gas I get and when carbon monoxide is burned in the presence of oxygen. 2CO plus O2 I get 2CO2 carbon dioxide. Here also the carbon dioxide molecular formula is one and the same. Means the carbon and oxygen are combined in a fixed ratio, nothing but definite proportions. So I read on it.
Yes, sir.
It states that a given compound always contains exactly the same proportion of elements by weight. So anywhere with carbon dioxide, the weight ratio is only 3:3. Same manner if I take water. So what if I react HCl when reacts with NaOH, sodium hydroxide? HCl when reacts with NaOH. What are the NaCl, sodium chloride plus H2? So again, one source of H2O. The other source, if H2O you will get from some other thing. I got H2O from this reaction, that is CaCO3, 2HCl is CaCO2 plus CO2 plus H2O. You take the H2O in this reaction, you take the H2O in this reaction. Wherever you look at the weight ratio between hydrogen and oxygen, so it's nothing but 2 is to 16. 2 is to 16 is nothing but 1 is to
2
1 is to 8. So this 1 is to 8 ratio between hydrogen and oxygen is constant. Then anywhere you go, whatever may be the source of water is there, the ratio between hydrogen and oxygen in water is always 1 is to 8 only. Okay? So that is nothing but law of definite proportions. Again, we are talking only in terms of weights. Means always the combining elements will combine only in a definite ratio. That is nothing but law of definite proportions. Next, one more law is nothing but law of multiple proportions. Again, here also it is nothing but a simple ratio only. Means one particular element combined with a different element in different simple ratios. Very simple to understand this one also. You know the oxides of carbon, nothing but CO, carbon monoxide, and CO2, carbon dioxide. And another, I'll get SO2, sulfur dioxide, and SO3, sulfur dioxide. So here the ratio is always simple ratio. So carbon is to oxygen, carbon monoxide, 12 is to 16. So oxygen atomic weight is 16, carbon is 12, 12 is to 16 is nothing but
6 is to 8.
nothing but 3 is to 4.
3 is to
4. So it's a simple ratio. The same manner in CO2, 12 is to 32. 12 is to 32 is nothing but 6 is to 16 and 3 is to 8. Again, it's nothing but simple ratio. Here 3 is to 4, here it's 3 is to 8, nothing more. Right? The same manner, if you look at the sulfur dioxide and sulfur dioxide, sulfur is 32.
32.
Oxygen is also 32. So 32 is to 32.
1 is to 1.
So it's nothing but 1 is to 1. And sulfur dioxide is nothing but 32 is to 48.
60.
So it's nothing but 68. It is 2 is 2 is 2. Nothing but 2 is 2.
2 is to 3, yes.
Yeah. So the by weight they combine in 2 is to 3 ratio, and irrespective of these two. Sorry, it's nothing but law of multiple proportions. Okay. So next, in case of Wilcox's law of combining volumes, again here also what we observed is the volumes of the gases which are combining with each other will also be done only in a simple ratio. Means, let us have a look at this equation. N2 plus NH2 gives rise to NH3. All the three are gases. Yeah, nitrogen, if I take one more, let us keep is nothing but one volume of nitrogen is combined with 3 volumes of hydrogen, giving rise 2 volumes of ammonia. So the combined volumes are simple ratio, and the products also in simple ratio. Same time, if I take SO2 plus O2, gives us SO3. So here also 2 SO2 plus O2, I get 2 SO2. So it's nothing but 2 volumes of SO2 combined with 1 volume of oxygen, giving rise 2 volumes of sulfur dioxide. Okay, it's nothing but Wilcox's law of combining volumes. Then finally, it's nothing but Avogadro's law, and you know pretty well. Avogadro's law states that equal volumes of all gases under similar conditions of temperature and pressure contains equal number of molecules. Equal number of molecules. So these are the 4 laws which are generally followed by all the chemical reactions. So laws of chemical combination are the laws which are followed by the chemical reactions.
Yes,
So
sir.
chemical reactions will be, they will follow all these 4 laws. So nothing but laws
Sir.
of chemical combination. So
Excuse me, sir.
I want to finish off this session for today. And if you have any queries, just mail me and wait for the replies. Okay?
Yes, sir.
And all the best for your holidays. But don't go anywhere outside. Sit at home. Spend more time with your books rather than spending outside. It doesn't mean that I'm not asking you to go out and play, but do some justice to your studies also. First place, 2 hours maths, 2 hours physics, 2 hours chemistry. In any 24 hours time, 6 hours be with your books, and the rest of the time do whatever you want. Okay? Watch movies, chat with friends, do whatever you want. But in any given 24 hours time, 6 hours should be with your books.
Yes,
Why?
sir.
Even the classes are over. Online classes are over. Okay?
Yes, sir.
All the best. And
Thank
see
you.
the colors while working. Okay? Anyway, I'll be in touch with you people by mail. Okay?
Yes,
Okay,
sir.
sir.
Yes,
Bye.
sir.
Bye.
Bye, sir. Bye, sir.
Happy holidays.
Thank you, sir.
Thank you, sir.
The thing is, I'm saying happy holidays, I'm not asking you to spend the time with books. So here, what I mean to say is, that you should be
Contradiction, sir.
happy while studying. Means you should enjoy while doing studies. So that's how the holidays can be happy. Otherwise, oh, in holidays we have lot of work. You feel bored or getting bored. So, no, not that way. When you are doing your chemistry, you should feel that you're eating a coconut, you know, right? When you are doing a puzzle, you should see. When you are doing your math, you should think that you are solving some puzzles. So usually in holidays we do the same thing, na? Solving puzzles and physics and something else. It's nothing but physics is nothing but
Puzzles.
huh?
Puzzle.
Chemistry is observation. Chemistry related to observation. Maths, imagination. And what about physics?
Practical.
Something more you need to think. Okay, we'll get back. I'll get back to you after some time. So anyway, enjoy while doing your studies. That is my slogan.
Yes,
If
sir.
you can't enjoy while doing your studies, you can't be happy.
Okay, sir.
So happy holidays means you should do your work, but at the same time you should be happy means you should enjoy while doing your studies. That's what I mean. Okay, thank you very much. Bye.
Bye, sir.
Rohan,
Yeah.
happy holidays. Bye.
Hey, tomorrow class is there, Ray.
I forgot. Sorry.
On 30th, you say.
Okay.
Ah, okay.
Bye.
What?